So in the last session, we were discussing the current in types of the circuit, series and parallel. So if we have a series circuit, the total current will be same. But if you have a parallel circuit, the current will divide between the components. And if you have a combination, then in a series part, the current will be same, but in parallel part, the current will be divided. So example, you have three components which are connected to each other. So because there is only one way for the charges to flow, so it means this is a series combination. If they have multiple ways to flow, we call that as parallel. So if I say there is a 5 ampere of a current is passing from the battery, 5 ampere of the current is coming out. How much current will be there in the first part at this point? What will be the value of the current? So it will be 5. Good. How much current will flow through this component? That will be 5. Yeah, that's good. Then same 5 will pass through each, and the 5 ampere will return back to the battery. So this 5 ampere of the current will flow throughout the circuit, the 5 ampere of a current, because in series the current is always same throughout the component. But if we have a parallel combination, like if we have component which are connected in parallel, so what we'll observe the current will divide. If we have multiple ways for the charges to flow in the circuit, or if the charges have multiple ways to flow in the circuit, we call that as parallel. In parallel, the current will divide. So example, when we connect them with a battery, when we connect them with a battery, if 3 ampere is entering, so if the 3 ampere enter the circuit, before the division it will be 3. But once the 3 ampere enter the branch, this is a point where they enter the branch. So if I say 1 ampere is passing from here, 1 ampere is passing through the second branch, how much current will pass through the third branch? If the total is 3, so what will be the current in this branch? So remaining 1 ampere will flow through this branch. So 1 ampere will flow. So 1 ampere from here, 1 ampere from this branch, and 1 ampere from the top branch. So all these current will join together or combine together at this point, and as a result it will make 3 ampere again, and that 3 ampere will return from to the battery. So the total current which enter the circuit is always same as the total current leave the circuit. So this is when we have a parallel, the current will divide between the component. If we have series, the current will be same throughout the component. And if we have a combination of a parallel and series, like example, we have say parallel first and then series, or first series then parallel, it won't make difference. So example, the components are connected here. So this is a combination. It contains series and parallel both. Two of them are series, two of them are parallel. So if we say 2 ampere of the current is entering, how much current will be here at this point? How much current will be there at this point before entering? It will be 2. But when it enter the branch, if 1.5 is moving up, how much current will flow down? Out of 2, 1.5 is going up. So the remaining 0.5 ampere will go down. And this 1.5 from here and 0.5 from here, when they combine, what will be the current? Again, it will be 2 ampere. And when this 2 ampere will flow, it will flow out in the same way. So the total current which enter the circuit is always same as total current leave the circuit. So when the 2 ampere is coming out from the battery, some of the current, like, it depends on if two identical are there, then equal division. But if they're not identical, if they're different components, then example, if 1.5 is moving from the top, remaining 0.5 will move from the bottom. But as we combine here, 1.5 plus 0.5, that make 2, and that same 2 ampere will flow into the battery. So the total current which enter the circuit is same as the total current leaves the circuit. And because to measure the current, we use a device, we call that as an ammeter, as this is a circuit symbol for ammeter. So how to connect an ammeter, connection of the ammeter in the circuit if you want to measure a current? So connection of ammeter, if you want to, what is the purpose of the ammeter? Ammeter is used to measure the current in the component, and it is connected in series with the component, because in series the current is same. So whenever we want to connect an ammeter, we should always connect an ammeter in series. So if I draw the circuit, like example, we have this, a circuit is there which is a combination of series and parallel. And say the question is, draw an ammeter. If I name these components, so this is R1, this one is R2, and this one is R3, and the first one is a battery. So if the question is, draw ammeter, number one, to measure current in battery. So if you want to measure the current in battery, so we should connect an ammeter, and ammeter should always connected in series. So how to connect an ammeter? So this is a battery, so I can connect before or after, anywhere I can connect it, either it can be before or after. So example, I connected before that, and symbol for ammeter is A, so make a circle A, so that is to measure the current in the battery. But if they say draw an ammeter to measure the current in R1, So if you want to measure the current in R1, so this is R1. So how we should connect an ammeter? Ammeter is always connected in series or next to that. So I can connect before or after, it won't make difference. So example, I connected after. So, and what is the symbol for ammeter? It is a circle with letter A. So it means this ammeter will read the current in R1. Same way, if I want to measure the current in R2, so I will connect an ammeter with R2. If I want to measure the current in R3, so I'll connect ammeter before and after R3. So if the ammeter 1 is 3 ampere and this ammeter 2 is 2 ampere, how much current will be there in this ammeter, which is in series with R2? If 3 ampere is coming from here, out of 3, 2 ampere is going in this branch. How much current will be there in this branch? What will be the reading on ammeter? So it will be 1 ampere. Good. So this will read 1 ampere. And if 2 ampere from here and 1 ampere from here, as a result, when they combine, they will give 3 ampere. So what will be the reading on the last ammeter? So it will be 3 ampere. So the ammeter are always connected in series to the component which we want to measure the current. And in series, the current is same. That's why we always connect them in series. Is it clear, the concept of connection of this ammeter, how we can connect in the circuit? Any question or doubt till this point? Now some questions related to topic electric current. As you can see here in this question, which circuit shows the direction of conventional current? So conventional current is always from positive to negative, and the electron flow, it is from negative to positive. So this is a positive terminal, negative terminal. So current, conventional current should be in this manner. That's correct. So conventional current is shown correctly. But what about the electron flow? This is positive, negative. So electron flow should be from negative to positive. So electron flow is not correct. When we check for B, the conventional current direction, I is the conventional current. So that is shown correctly. And plus and minus, so negative to positive is the electron flow. So that is also shown correctly. So means B is the right answer for this. Why not C? Because positive to negative is a conventional current. So direction of the conventional current arrow is wrong. When you check positive, negative, again the direction of the conventional current is shown incorrect. Even here, the direction of the conventional current is shown wrong and direction of electron flow is also wrong. In this one, direction of conventional current is wrong but electron flow is correct. In this one, both the directions, because from positive to negative conventional current, negative to positive electron flow, so both directions are correct. Then which particle in the metal moves that cause an electric current? So current is basically a movement of the charges. So in the metal we have electron. So electron flow is responsible mainly for current. Then a metal conductor is connected to a battery. Which statement describe the current? So what is the concept of the current? It is electron and proton does not flow because you don't have protons in the metal. You have a positive ion and delocalized electron in a metal. So A and B, C and D cannot be an answer. So it is an electron flow. And which direction the electron flow? Electron always move from negative to positive terminal. So it's a flow of electron, and that is from negative terminal to the positive terminal. And when you check the other question, in electric circuit, there is a 40 coulomb. So this is a charge passing in 5 seconds. So this is the time. What is the current in the circuit? So how to get the current? So current is equals to charge divided by time. So charge is how much? It is 40 coulomb and time is 5. So 40 divided by 5. So you will get 8 ampere. That's why B is the right answer. Because the current is basically the rate of the flow of charges. Is it clear till this point? Then another question. So which row describe the conventional current and the electron flow? So conventional current is what? Conventional current is the movement from positive terminal of the battery. Like if there is a battery, so if there is a battery positive and negative terminal, so what is the conventional current? The conventional current is from positive terminal to the negative terminal. That's we call as a conventional current. But if we have a battery and we want to show the electron flow, so what is the electron flow? So electron flow is from negative terminal to the positive terminal. So which option is correct? Conventional current. What is the conventional current? It should be from positive to negative. So A is wrong, B is wrong accordingly. So it is from positive terminal of the cell to the negative terminal of the cell. So C can be an answer, D can be an answer. What about electron flow? Electron flow is from negative to positive. So negative terminal of the cell to the positive terminal. So this option is correct. And here positive to negative, the conventional current, that is correct. So which is the right option? C is the right option. Is it clear, this part? The electron flow and the conventional current? So another one, as you can see, a cell is connected to a lamp. A charge of 4 coulomb is in 2 seconds. What is the direction of electron flow and how much, what is the current? So how to find the current? The formula for current is charge divided by time. So charge is 4 and the time is 2. So 4 divided by 2, that's equal to 2 ampere. So the option with the 2 ampere, either A can be an answer or C. But what about electron flow? Because this is a negative terminal, so electron move from negative to positive. So they're asking what is the direction of electron flow in the lamp. So this is a lamp. So this is the right side of the lamp and this one is the left side of the lamp. So how the electrons are moving in the lamp? From left to right. So it is 2 ampere and they're moving from left to right. That's why A is the right answer. Is it clear? Then another question. This one is not having a current question. So direct current question, yeah, is not there. So this was about the electric current. So quickly I will repeat what we discussed today. So we started with the concept of electric current. Electric current means it's a flow of the charges, rate of flow of the charges. Conventional current is from positive to negative, where electron flow is from negative to positive. And if we want to measure the current is how much charge flow through a circuit every second. So it is charge divided by time. And if we want to measure the current, we use a device which we call an ammeter. And example, if 60 coulomb is passing in 10 seconds, so 60 divided by 10, 6 ampere. But in the second example, if 150 milliampere, you have to convert into ampere, divide by 1000, and time is in minutes. Time should always be in seconds, so it is 3 minutes. You should convert into second, multiply by 60. Then charge is current multiplied by time. So current is 0.15 and time is 180, so it will be 27 coulombs. And current can be alternating. Alternating means the current changes the direction continuously, and direct means the current does not change the direction. So we are done with topic electric current. The next session we will do about voltage and electromotive force, or known as EMF. Any question or a doubt related to the class today?